The soda is a true solution. What about this soup? Tomato soup is not clear like soda. It is not homogeneous. We can see some solids dispersed in a liquid. The dispersed solids are big and are not soluble. As they are not uniformly distributed, this is a heterogeneous mixture. Sometimes you may also come across fruit pulp suspended in juice. When mud is mixed with water, you will find soil, clay, and silt particles suspended in water. Let us study another example of suspension. Take a tablet and crush it into a powder. Add a small quantity of the powdered tablet to honey. Check if the tablet is soluble. As you see, the powder is insoluble in honey. Instead, the tablet particles are dissolved. These are some examples of suspension. Flour in water is a good example of suspension. The flour particles are big and visible in the medium. When we pass light through the suspension, it is partially blocked because of the bigger size of the suspended particles. We can see the shadow of the glass on the other side. However, the suspended particles settle down when they are not disturbed. When the suspended particles settle down, the upper layer becomes transparent and allows the light to pass through. The phenomenon of scattering of light by the dispersed particles is called the Tyndall Effect. A good example of Tyndall's effect is the scattering of sunlight by the colloidal particles dispersed in air. Here is a glass of milk and a glass of flour mixture. The flour-water mixture is a suspension, and the flour particles settle. The milk is white, but the suspended particles are not visible and do not settle down. The flour mixture is not stable and scatters light. Even though there are no particles visible in the milk, it also scatters light. When filtered, the flour is retained in the filter paper, whereas the milk passes through the filter paper, leaving no residue. Milk is a colloid. The particles of a colloid are uniformly distributed throughout the bulk of the solution. The size of the colloidal particle is bigger than the solute particle in the solution and much smaller than the suspended particles in the suspension. Since the colloidal particles are smaller, they are not visible to the naked eye, but visible under microscopic observation. A colloidal solution consists of two parts: the dispersed phase, or particles, and the dispersing medium. The dispersed phase constitutes the smaller part, and the dispersing medium occupies the main part of a colloidal solution. Both the dispersing medium and the dispersed phase can be solid, or liquid, or gas. There are different types of colloids: sol, emulsion, solid sol, gel, foam, and aerosol. Let us consider honey. It is neither a solution nor a suspension. The dispersed particles are not visible clearly to our naked eyes. However, they can be viewed through a microscope. Though the dispersed particles in a colloid are smaller than in a normal suspension, they are big enough to scatter the light passing through them. This is called the Tyndall Effect. Unlike suspension, colloidal particles do not settle down when they are left undisturbed. They produce a stable substance, like a solution. We cannot separate colloidal particles by ordinary filtration. However, the dispersed particles will settle down on centrifugation.